Hello, everyone. So in this session, I'll be showing you how to implement content-based filtering or recommender systems. So first, we import some libraries. We're just using NumPy and Pandas. We'll be implementing things from scratch. And as for the data, we will be using the movie lens dataset. I've already pre-processed the data, so it will be easier for us to process later on. So you just use the following path. I've already, again, pre-processed that here. We save it in the DF ratings data frame. So we end up with the following data. We will also be using the DF genres dataset from the movie lens dataset. So this is what it looks like. So now that we have the ratings and the genres, we can now combine them and create a utility matrix. So again, here are the steps. We first build the item profile matrix, and we will be focusing on user ID 1 for now. We will compute the user profile. We will be ignoring the ratings column for now. That's for implicit rating. We recommend movies that the user has not watched based on the genres. So we'll be using sklearn's built-in cosine similarity function. But we can simply create this on our own if you want, but just to make things standardized, we will be using the cosine similarity from sklearn. Okay, let's start with the building of the item profile matrix. So we have the DF genres here. We drop the title. We only want to get the genres here, of course. So this is what it looks like. Now, we will be computing the user profile for user ID 1. So we query user ID 1 and we get the movies that user ID 1 have watched. So these are those movies, and we locate them, we find them, and then get the mean of those movies. So you end up with the following user profile. So for action, you have 0.38, for the adventure, you have 0.36, for animation 0.12, and so on and so forth. Right. Now we want to take note of the top genres here. You should be seeing that the recommended movies have these genres, more or less. So this user is into action, adventure, comedy, drama, and thriller. That's what I'm seeing here, based on the values. Now we will be retrieving the similar items. So you get the scores, okay? We apply cosine similarity using the DF item. Again, that's the full item matrix. If you look here, what was that again? Here, this is all the items that we have, all the movies and the genres. This is our matrix. And then we calculate the distance of the user profile. This represents user ID 1 for us. This is our profile, and we check the similarity of all the items with the user profile. Now we just simply save that similarity score somewhere here. It's going to be at the end. And now you end up with the scores for all the movies. If we look at the recommended movies, you will see that it's consistent with our user profile. So hold on. Let's, of course, sort it based on similarity. So you will end up with the following matrix. But we have also done, we have also filtered out the movies that the user has watched, because we don't want those. So the user already watched that, so we're not going to recommend that again. That's what this thing does. And finally, I'm simply looking at the top 10 movies, and I just transpose it for visualization purposes, so it's easier to look at. So the first movie that is recommended here is Dragonheart 2. And look at the genres for Dragonheart 2. It is action, adventure, comedy, drama, fantasy, and thriller. What is our user profile again? It's pretty much the same. It's action, adventure, comedy, drama, thriller. And you will be seeing the same pattern for most of the movies here. You will generally see those genres. So just by looking at this, we can clearly see that it has recommended the correct movies. You're seeing the scores here. You can simply change the value here so that you could recommend more movies if you want. Again, that's for implicit rating. Now let's proceed to explicit rating. So we do the same steps. We get the user profile. So in this example, we will be using user ID 3. We simply do some EDA. So this user generally do rate quite low, I would say. There's a 0.5 here and there's 20. And there are many, well, 20, 1, 1, 1, 1. So yeah, the user doesn't generally rate high from what I can see here. Although I'm seeing 5 counts for 4.5 and 10 for 5.0 here, but for 0.5, there's a lot, there's 20. So we're expecting low ratings generally. So as you can see here, it's 2.4. That's the mean of the user ratings. Now we apply those ratings to the item profile matrix. So we have the DF ratings, so we check the ratings of that user, filter that, and then we check the ones that the user has watched, and then times the user ratings. And then we replace the nulls with 0. So we end up with the following item profile matrix here. Lots of 0.5s. Now we compute the user profile. So we will now end up with the following user profile. As you can see, the values here are quite low for some of them, right? So action has 3.5, adventure has 2.7, so on and so forth. Now we again take note of the top genres here. Again, you should be seeing that the recommended movies have the same genres, more or less. So this user is into mystery, horror, sci-fi, thriller, action, based on these ratings. And we also look at the genres that this user does not like. So this user is not into romance, film, noir, IMAX, documentary, Western. Mostly zeros. Okay, we retrieve similar items based on that profile. So we do the same thing, same code, but this is for user ID 3 now. And this will be the recommended movies. So it is also consistent with our user profile. So the user here, well, the first movie that is recommended to us is Night Watch. So it's an action, fantasy, mystery, sci-fi, thriller. The horror, yeah. Pretty much the same, mystery, horror, sci-fi, thriller, action. Correct, right? Same goes for a cave, pretty much the same, pulse, same. So we have recommended the correct movies here. And these are the movies that this user will not probably like. So we have, what's this? Just Eat It, documentary. Yeah, mostly documentaries here. what's this? Western, right? Western, Rio Bravo, Kiss Me Deadly, film, yeah, basically the genres that we have seen earlier that this user does not like. Okay, what else? We also have the explicit rating mean subtraction variation. So again, we use the same user ID 3. We filter out the ratings here. Okay, we do some EDA. Yeah, we've already seen that earlier. This is the user ratings 2.4. Okay, now we apply the ratings to item profile matrix. It's the same thing, but we have applied the mean subtraction variation. This is the only thing that has changed. We have added this line here. So you can see the mean here, we subtract it. And now you end up with the following values here. It's negative, generally negative. Okay, now let's compute the rest. It's the same code that we're using it. It's just that we added the user rating mean subtraction. That's really it. So what will be the top genres based on that approach? It will still be mystery, horror, sci-fi, thriller, action. I have a question here. So what if we try to get the user profile of user ID 1 instead? Note that the ratings made by that user are highly imbalanced, unlike this user. So let's see. Wanna see your answers here. Okay, again, I do the same stuff here. So I also check the genres that this user does not like. So it has range here. For the genres that the user likes, it's generally the same for this variation, the mean subtraction variation. But the genres that this user does not like, they have changed. So it's now musical, romance, children, animation, war. So now let's compute the similarity, same code, same everything. Of course, it's generally going to be the same for the recommended movies, but for the ones that this user would probably not like, it has changed. So the first here is Hunchback of Notre Dame, and it's animation, children, drama, musical, romance. Again, because that's the user profile for the movies that we don't like. Musical, romance, children, animation, war. And the same applies for the rest. And that's it for the implementation of content-based filtering. Hope you found that useful.